So let's practice finding the derivative through the long way, the formal definition. A lot of people start to forget about this once they learn all the little tricks like the power rule and product rule and all those things. But you still got to remember where the derivative comes from, and it comes from this formula. It's the limit as h goes to 0, f of x plus h minus f of x all over h. This is the original way we found the derivative, and it's where it stems from. All the shortcuts that we learn in class were found after learning the limit process. So we really got to make sure this is our foundation. And basically, this is the really long way of finding f prime of x. So I want to do a couple of examples just to kind of practice. We want to make sure you have this down a little bit. So let's say we have this. Let's say we have f of x equals a fraction, 5 over x. And for some reason you want to know, what does f prime of x equal? What's the derivative? And we're going to find it using the limit process. So here's how you go about it. I'm going to move this up. You set up your formula. You say, okay, f prime of x is going to equal the limit as h goes to 0. And we're going to do f of x plus h. So everywhere there's an x, we add a plus h. So instead of 5 over x, it's 5 over x plus h. Minus f of x, so 5 over x, all over h. And there's our limit. That's the thing we got to solve. You can pretty much never plug and chug because h is going to 0 and you can't put a 0 in the denominator. So you're always looking for other ways to solve these limits, so they're always a little bit tricky. The thing with these fractions is we should try and combine all this together with common denominators. So what I'm going to do is I'm going to take the x down below here and I'm going to multiply it by the x plus h. And I'll do the same thing on top. Multiply the top and bottom. And then on the opposite side, I'm going to cross over here. I'm going to do x times all of this. So I'll put a parenthesis here. I'm going to times this by x and the top by x. And then we'll kind of push all this together into one big fraction. So let's rewrite this. It equals the limit as h goes to 0. We now have 5 times x, so 5x, minus 5 times x plus h, all over this common denominator that we've put together, so x times x plus h, and then still all over h. So it's ugly. It's this big triple fraction thing. But we're going to clean it up. We're going to distribute the 5 in. That's a good step right now to do. So I'm going to rewrite this as the limit as h goes to 0 of 5x minus 5x, and then negative 5 times h is a negative 5h, minus 5h, all over, I don't think I'll multiply the denominator, x times x plus h. And then technically it's all over h again, but instead I'm going to write times 1 over h. I'm going to bring this bottom part of the fraction up so it looks like that. And then we see some cancellations. We see 5x minus 5x, so that's going to be good. And we can rewrite this as the limit as h goes to 0. We now have a minus 5h all over x times x plus h, times this thing, 1 over h. And the next thing that's going to cancel is these h's. These two h's are going to go away. So now I have the limit as h goes to 0. I have negative 5 over x times x plus h. And I'm ready to plug in my 0. I'm going to put 0 in for h, and I'm going to get equals negative 5 over x times x plus 0. I no longer have to write the limit as h goes to 0 because I'm plugging in. So I'm ready just to get an answer here. And if I do x times x, I'm going to get x squared. So let's do good notation. Let's write this at the bottom. Equals negative 5 over x squared. And really, this is my answer. This is my f prime of x, my derivative. So I'll put a box around this thing, and we're done. Limit process. So that's kind of how you do a fraction one. You really should have that down. You should practice a few and make sure you can do it. It's easy to check our answer. We could have used the power rule. Remember what we started with. It was f of x equals 5 over x. The power rule is super fast on this. This is really 5x to the negative 1 power. So if I was going to power rule this thing, multiply the negative 1 down. So f prime of x equals negative 1 times 5, x to the negative 1 power, and then subtract 1. Do the power rule, which is negative 5 x to the negative 2 power. And we don't like negative powers, so we move it down, and we say it's negative 5 over x to the 2 power. The exact same answer we just got. So I know I did my limit process right. Now that you know the power rule, you can pretty much check all your answers just like this. It's 10 times faster, I know, but we got to be able to show that limit process. So we're doing a little bit of both now. It's actually kind of hard to slow yourself down once you know the shortcuts. So let's try one more for the video. Example 2. Make sure you're able to do problems with square roots. So like f of x equals the square root of x minus 4. I want to know the derivative. You should be able to. We can't use the power rule on this one. So we need the limit process currently. So we need to set this up. F prime of x equals the limit as h goes to 0, and then we're going to add a plus h. F of x plus h. So we're going to have square root x plus h minus 4 minus f of x, so minus the square root of x minus 4, all over h. And there's our limit. That's the thing we're going to solve. Square root problems, usually we use the conjugate. So I can tell that I'm going to go to the side here and multiply by the conjugate, which is basically the opposite of the top thing. Instead of a minus, we're going to have a plus. So square root x plus h minus 4 plus the square root of x minus 4. And we're going to do the same thing on bottom. Square root x plus h minus 4 plus the square root of x minus 4. And so let's clean this up. The limit as h goes to 0. We'll rewrite that. When you multiply the square roots, they drop. So now we're going to have a quantity x plus h minus 4 minus a quantity, and then when you multiply these, they drop, so x minus 4, all over h times all this stuff. I always leave it as h times parenthesis, all this junk. So x plus h minus 4 plus square root x minus 4. You could multiply the h in, but there's no need. I'm going to leave it be. Next thing I'm going to do is I'm going to distribute this negative sign in. That'll be my next step. So I'm going to write equals the limit as h goes to 0. On top we've got x plus h minus 4. And then distribute the negative sign in, so we're going to have a negative x plus 4. It'll change the sign. All over h times all that junk, square root x plus h minus 4 plus square root x minus 4. And things cancel. So we've got x minus x, negative 4 plus a positive 4. The only thing left on the top of this fraction is an h. So we have the limit as h goes to 0. We rewrite this as h over h times square root x plus h minus 4 plus square root x minus 4. There it is. And now the last thing left to cancel is the h's. So those cancel. The fraction hasn't gone away. That's what people have been doing in class accidentally, is like getting rid of the entire fraction. It's not true. Once you cancel, what's left is a 1 on top. So when you rewrite the limit, you got to be really careful. The limit as h goes to 0. We're going to have 1 over, still all of this stuff, square root x plus h minus 4 plus square root x minus 4. But now we're ready to plug and chug. We can put the 0 in. We can put the 0 in for the h and get equals 1 over square root x plus 0 minus 4 plus square root x minus 4. Which in reality, these are the same thing. So if you're adding them together, you've got 2 of them. So we've got 1 over 2 square root x minus 4s. 2 square root x minus 4s. And that's my answer. That's my f prime of x. So the limit process when you read directions, if it says anything about the limit process or the formal definition, so limit process or the formal definition, those are clues that you have to do this longhand way of finding the derivative. And you can use the shortcuts and you can always check yourself, but if you see either of these terms, either of these words, you've got to go through the longhand way. So hopefully you've kind of practiced. Hopefully this helps a little bit. I'm sure we're going to quiz in class on this. So keep up those limit skills. All right, see you in the next video.